Hi everyone! In our previous video, we went over the general framework of a predictive model. I'm hoping that you have already seen that video before continuing on to this one. In this video, we're going to go over a more specific example of predictive models from healthcare, where we're going to predict whether a person is healthy or unhealthy given characteristics about their weekly diet. So let's get started. Okay, so let's go over example with actual numbers. So hopefully this will make a lot more sense. So now I'm being a little bit more formal and introducing indexes. So we have our outcome y. yi is equal to 1 if I is unhealthy. Okay, so now we're looking at like a healthcare example. So first let me just tell you what this I is. The I stands for individual. Okay, so I is essentially a person. So the first person, the second person, and so on. Yi is equal to 1 if I is unhealthy, and yi is equal to 0 if I is healthy. So this is again a binary outcome. It takes on two values. A person is healthy or unhealthy. Okay, so now you can imagine that a person's health depends on their characteristics, such as how much exercise they have, and what kind of diet they have, and what kind of risky behaviors they participate in, and so on. So suppose we have some data, and in the data we know whether a person is healthy or unhealthy. That's already labeled for us, and we have these three features. All of these features are measured on a weekly level. So let me just highlight that. So units per week. So we know on a weekly basis how many cigarettes the person smokes. We know, for example, in liters, how much alcohol they consume per week. And we also know how many calories they consume per week. So we have these three characteristics. And what we want to do is we want to predict yi, we want to predict whether they're healthy or unhealthy given these features, x1i, x2i, alcohol usage, and x3i, which is calorie intake. Okay, so that's our goal. Now, to accomplish this goal, suppose we have a predictive model. So essentially we have p hat of xi, and this is essentially the same thing as the probability hat for estimator, the probability that a person is unhealthy given its features, its characteristics, xi. And something I should mention, what we mean by xi is a vector containing the number of cigarettes per week the person smokes, the alcohol consumption per week, and the calories per week. So let me just write that here. So xi is a vector consisting of x1i, x2i, and x3i. Okay, so it would be perfectly fine if xi was replaced by x1i, x2i, x3i. I'm just using xi because it's much simpler and fits better on the screen. So this model says the probability that a person is unhealthy is equal to this intercept 0.03 plus 0.04 times the number of cigarettes they smoke per week plus 0.02 times the alcohol consumption they have per week plus 1 over 35,000 times the calorie intake they have per week. And something I should mention about this model is this is a linear model. So the predicted probability is a function of the data, but the key here is that this is a linear function of the data. And there are nonlinear predictive models, and we're going to get into that in later videos. But right now, we're just being as simple as possible so we can understand the key ideas. So suppose we have this predicted model. We're going to use this model to predict whether a person is unhealthy or healthy. So let's do that next. So now here we have actual data, and I should mention this is of course made up data, but suppose you had a spreadsheet like this. So you have data on 1,000 people. So here n equals 1000. We have a sample size of 1000. We have our predictive model up here that we're going to use to predict whether a person is unhealthy or healthy. For each person, we know the amount of cigarettes they use per week, the amount of alcohol they consume in liters per week. We know the amount of calories they consume per week. And the last column here is the outcome y. So 1 means, so remember, so y equals 1. So y equals 1 means that they're unhealthy. And y equals 0 means they're healthy. Okay, so here on the last column, we have the label for whether they're healthy or unhealthy. So y equals 1, person 1 is unhealthy, and also the last person, person 1000, is also unhealthy. Now you'll notice I have the fourth and fifth column. I haven't entered any data, and that's what we're going to figure out using our predictive model. So p hat of x is the probability the person is unhealthy that's implied by the predictive model. So let's first compute p hat of x for both person 1 and the last person, person 1000. So p hat of 1 given x1. So this is the probability that the first person is unhealthy given that they smoke 10 cigarettes, 1 liter of alcohol, and 18,000 calories all per week. Okay, so let's plug in the data point into our predictive model. So we have 0.03 plus 0.04 times the number of cigarettes they smoke per week, that's 10, plus the amount of alcohol they consume per week, which is 0.02 times 1. 1 is the amount of alcohol they consume per week in liters, plus we have 1 over 35,000 times the amount of calories they consume per week. So here we have 18,000. Okay, so now we can plug this into a calculator and compute this number. I believe this turns out to 0.96. Before we do that, so what the 0.96 means is that the probability that this person is unhealthy is 96% according to this model. So let's just put in 0.96 in here. Okay, let's do the same thing for the last person, person 1000. So we're going to predict the probability that they're unhealthy using this model. 0.03 plus they don't smoke any cigarettes, so we don't need to worry about this term. 0.02, they consume 0.2 liters of alcohol per week, plus times 0.2, plus, and they have 14,000 calorie intake per week. 1 over 35,000 times 14,000. And once you compute this, I believe this turns out to be something like 0.44. Okay, so we can plug in 0.44. So the probability that this person is unhealthy, given the amount of cigarettes, alcohol, and calorie intake on a weekly basis, is 44%. Now, using these probabilities, we need to make a prediction. Right now, we just have a number between 0 and 1, which is the probability. We haven't actually made a prediction on whether the person is healthy or unhealthy. And our prediction is going to be y hat. Now, how we're going to make our prediction, and I think this is pretty sensible, is we're going to say y hat, which is the prediction made by the model of whether the person is unhealthy or if the person is healthy. We're going to say y hat is 1, meaning the person is unhealthy, if the p hat we compute, if p hat the probability that they're unhealthy is greater than 0.5. And similarly, we're going to say that they are healthy, where y hat is 0, if p hat, the estimated probability that they're unhealthy, is less than or equal to 0.5. Okay, so that's how we're going to be making our prediction. So in this case, y hat, we know for the first person there's a 96% chance, according to our model, that they're unhealthy. That's more than 50%, so we're going to predict they're unhealthy. Now for the last person, there's only a 44% chance, according to our model, that they're unhealthy. So we're going to put a 0 here. That we're going to predict that this person is healthy. Now you can see that for the first person, our prediction is correct, but for the last person, our prediction is actually wrong. The last person is actually unhealthy, but we predicted them to be healthy. So we're incorrect for the last person. So once we compute our model, our predictive model, we can use it to predict whether y is equal to 1, meaning that the person is unhealthy, or whether the person is healthy, where our predicted value is y hat is equal to 0. And once we get our prediction, what we can do next is we can check for accuracy to see how good is our predictive model. And one measure of accuracy can be is how many of the predictions in y hat actually match up with y, like how many of the predictions that we made are actually correct. And there's many different forms of accuracy for a predictive model, and we're going to be talking about different types of accuracies in future videos. But in this video, I just wanted to introduce the idea of a predictive model.